Okay, so this is going to be a demonstration of how to find the minimum delta in a list of numbers. Delta just means difference. So we're looking for the smallest difference given a list of numbers. In order to do that, the first thing I've got to have is a list of numbers. So I've created a method in this program called create random array. We tell it how big we want, how long we want the list of numbers to be, that is, and then it fills it up with random integers less than 100. So you can see in this first line of code here, we say create an integer array called number list, and it's going to have 15 items in it, and they're all random. Let's see what happens if we loop through this. So let's go ahead and set up some code to loop through the array. Okay, so I've got my list of numbers. I've got an index counter that's going to count up to however long that list of numbers is. And now I want to print out each number that's in my list of numbers so that we can see it. We can see what's inside that random array. So what I'm going to do here is I'm going to say number list is the name of my array. And the item that I want to look at right now is going to be called current index. All right, very good. Let's run this and see what happens. Okay, there it is in all its glory. I have 15 random numbers. Excellent. So now that I know that I can have some random numbers in my list to play with, I want to do some additional stuff. So let's say that I'm trying to find a target number. Let's call that int target number equals 62. Let's call it 42. Okay. So target number is 42. Now what I'm looking for is I want to know the minimum absolute difference. I say absolute because I don't care if I'm higher than the number or lower than the number. I just want to know what's the smallest absolute difference. So I'm going to create a variable to store that, and I'm going to call it absolute difference. That makes sense, right? Boom. Now, if you recall earlier in the class, and you may not, when we're looking for a minimum, we start with a ridiculously high number. So I'm going to start with 1,000 because I know that pretty much everything should be less than 1,000. So as we iterate through our loop of numbers, we're just going to keep getting smaller and smaller. Okay, before I get back to talking about finding that minimum difference, or delta, I want to show you something real quick. So this number column on the right, let's say this is the list of numbers in our array. The column on the left, these are the indexes. So the index for 55 is 0, the index for 26 is 1, the index for 13 is 4, the index for 15 is 5. So kind of have that in mind. And you can imagine that the column on the right is our array that we're working through. So we need to know not only what is the minimum absolute difference that we can find, but we also need to know where can we find that? What is the index of the number in our array that gives us that minimum difference? So we have to store that as well. Right now I set it to -1 because I know that that's an invalid index for an array. So let's tweak this code a little bit more now. Okay, I took a break and came back, so I'm going to have to take this from the top. I apologize that this will be a little redundant, but let's walk through what's happening in this program. We'll go ahead and run it, and then you can download the code and try it for yourself. So, at the very top, we create a list of numbers. These are random numbers. There are going to be 15 of them. 15 is this part right here. And we want to see how close we can get to a target number. I used 42 here. I would like to see you change this to some other number, and I'd also like to see this 15 change to something else when you try this code. We need to know what that minimum absolute difference is, so we start with an impossibly high number. If we were looking for a maximum difference, we would start with an impossibly low number. So we're going to store this as we go through processing. And we need to know which element in the array produces that smallest difference. So again, our index in the array is never negative, so I start with a -1. If I get to the end of my program and this still has a -1 in it, I know that I have an error someplace. Now we're going to use a for statement, and we're going to loop through the array. So we start at item 0, so we put that into a variable called current index, and we're going to go as long as current index is smaller than the length of the array. We're going to add on to it as we go. So the first thing we do is the current number is whichever item is at the current index location in the list of numbers. So in other words, first time through we're going to look at item 0. Next time through we're going to look at item 1, which will be the second item in the array, etc. So if you think back to what we looked at in that other list I showed you, we're just working through the list. Okay, so at this time we want to know what's the absolute difference between the target number and the current number. So we do the math. We use math.abs to give us the absolute value of that difference. And if that absolute value difference is smaller than whatever we have stored in minimum absolute difference, then we're going to set minimum absolute difference to that current smaller amount. In fact, let's improve our code just a little bit here. Boom. And we'll need to know what index produces that result. And so we're going to put the current index into this variable where we're storing our index for later use. And then just for debugging, we're going to print out which index we're working with right now and which number shows up at that index location. Once we're done looping through, the final answer, the number that produces the smallest absolute value difference, can be located at the index that we stored earlier inside our list of numbers, the array. And then we're just going to print out a whole bunch of information below. Let's run this and see what happens. So the target number was 42. Yep, didn't change the code. We had items 0 through 14. That's a total of 15 items. The minimum difference was 2, and that was produced by 40. Awesome. Let's run it again. Minimum difference was 1. Was produced by the number 43, again at the end of the array. That seems improbable, doesn't it? That's a little better. This one was in the middle of the array. Index number 9 gave us the smallest difference.